Hello and welcome back to another video of Leetcode solutions. In this video, we'll be solving this question, longest substring without repeating characters. Given a string, we want to find the length of the longest substring which has unique characters. Let's look at a simpler problem. Figuring out if a string has unique characters is fairly easy. We just iterate through the string here and keep track of the letters we saw. If there is a repeated character, then this string does not have unique characters. If we can iterate through the whole string, then we have a string with unique characters. Using this approach, we can check for substrings of various lengths until we find a string with this property. Since we want the longest one, we can start from the longest length and go shorter, trying every possible combination until we find the correct solution. Using this solution on this string, we had to go through 14 strings until we found the solution. This solution does not scale well with long strings and especially with strings consisting of only one letter. We need a solution that goes through the string only once and with whatever length or structure it has. To implement a solution like that, we need to save some information about what we have seen already. First, we can have a variable that tells us where we are sure a string with unique letters begin as a start. This will be the first character of the string, so at index 0. I will indicate this with a yellow color for the rest of this video. Another variable we will need will be the max length of a string with no repeating characters. As a start, it is 0 as we can get an empty string as an input. Finally, we need to store when was the last index we saw the character. We will do that in a hash structure such as a table. Let's see how this will work. So for each character, we need to check if you already saw it or not. For the first character A, we did not see it before, so we just add it to the table with its index. We then go to the next char B. Again, since we did not see it before, we add it to the table. We go on to the next char C. Again, we did not see C before, it is added to the table. We go on to the next char A. Here it gets interesting, since we saw that A before. Now we know that if we continue, we will have a string with duplicate letters. But before that, we are sure the string before this A has unique letters. We need to check if its length is more than the max. Since our max was 0 and this string has a length of 3, we update our max. We then need to update our start. Since we know that the last A we saw was at position 0, we are sure that the string starting from the next index, which is at 1, at that B, has unique letters, so we update the start to 1. We then update our table with the current index. Let's continue with the next letter. Again, we saw a C before. We check the substring starting from start. Its length is also 3, so no update is needed. We then update our start with the next letter from the previous C we have seen, which is at position 3. And finally, we update our table with the current index. Let's move on with the next letter. Again, we saw a B before, so we follow the same steps as before. We check for the length of the string starting from start. It has a length of 2, which is not more than our max. We then want to update our start. If we follow our approach of choosing the next index, this will give us a wrong answer because we will choose this C highlighted in orange. As we can see, this is clearly wrong as there is another C in the string at position 4. The issue is that this index is before our current start, which is the position which we are sure that there are no duplicate letters. So to solve this, we need to always check if the next index is after our current start. Then only we can update. In other words, we select the maximum between the current start and the new candidate index. Going with this, we keep our start at 3. We then update our table. We go on to the next position. A D is a new letter which we did not see before. So we just add it to the table. We go to the next char, which is B that we saw before. Following the same steps, we check if the string starting from the start has a length longer than our max. This time it has a length 4, which is more than our max, so we update it. We then update our start with our strategy, which is the previous B location plus 1, and since it is more than our start, then we update it to 6. We then update the table. Now we have finished the string, but as a corner case, the longest unique substring can be at the end. We need to check for that. As an extra step, we need to check from start until the end of the string. Here its length is less than the max, so we do not update. So now we see that following this solution, we get this substring as the longest one without repeating characters and its length is 4. It's very clear that this approach is much more efficient than the one we introduced in the beginning. So let's code this now. We will have our variables as we said. A start one with an initial value of 0, a max with an initial of 0, I will name it M since max is reserved in Python, and finally our table, which is just a Python object. We then loop through the length of the string. We check if the char is not in the table, and if not, we just add it to the table and its index. Else, meaning if we find it, we check if the string starting from start is longer than max. We can just use the predefined max function here and compare between the previous m and the length of the string, which we can get by subtracting our index from the start. We then need to update the start. As we said, it is going to be the max between the current start and the next index of the last occurrence of the current letter, which is the table of s of I plus 1. And finally, we update the table. To make this look cleaner, I will just remove this repeated line here, and I will update our condition. So if it is in the table, we do the update of the max and the start, and in both situations, we just update the table of s of I with I. Finally, we need to check if the length of the last substring is larger from our max or not. We can do that by subtracting the length of our string from the start. And finally, we return the max. Let's test it. Works great. Let's submit it. We can see it got a 93% runtime, which shows how efficient it is. That's it for today's video. See you in the next one.